Chapter 4, Lesson 5 deals with the coordinate plane. The content objective is students will identify ordered pairs, points, and quadrants and graph ordered pairs on the coordinate plane. The suggested pacing guide says this is going to take 135 minutes to complete, so probably looking at a solid 2-day lesson on this one. Let's get started. Did you know that the locations on the Earth can be described similar to how locations are described on a coordinate plane? The equator is the imaginary line that divides the Earth into the northern and southern hemispheres, and the prime meridian is the imaginary line similar to the equator that divides the Earth into the eastern and western hemispheres. The equator is similar to the horizontal axis of a coordinate plane, and the prime meridian, well, it's similar to the vertical y-axis on the coordinate plane. The equator and your prime meridian intersect at the Gulf of Guinea, just off the western coast of Africa. What location in the coordinate plane is similar to this location, and how do you determine this? Well, that location would be the origin where your x and y axis intersect each other. Wow, we have 11 slide sets in this resource, and it wants to know how are integers and rational numbers used in the coordinate plane. So let's learn what they have to say. Legend says that one day, philosopher and mathematician René Descartes noticed a fly walking on the ceiling. Descartes realized that he could describe the fly's position on the ceiling by two numbers, its distance from each of the two walls. Thus was born the coordinate plane, also known as the Cartesian coordinate system, after Descartes. I guess maybe Descartes was Cartesian? Could be. What do you know about the coordinate plane? How have you used the coordinate plane in the past? I bet you probably know more than you remember, but we're going to get through this and learn even more today. So right here we have a model of Descartes' ceiling, and the orange dot, well, that represents the fly. And you can see the fly can move anywhere through the ceiling, and as it moves around on the ceiling, the numbers representing its new location based off of its original location changes. So this is how the Cartesian plane, or the coordinate plane, was born. Now they want us to drag the fly to each of the four corners in the coordinate plane and that they have here, and then log their coordinates on the table. Now remember, your x is going to be your horizontal, your y is going to be your vertical. So let's start off with the bottom left, since it's there already, and the bottom left has both of those listed as 0.00. Now if we take and drag our fly over to the bottom right, what do we have? We have 0.60. So our x-axis is 6, our x value is 6, our y value is 0. Now we're going to take our fly and move our fly all the way up to the top, and we have the top right is going to be, the x-axis is going to be 6, the y-axis is going to be 4, and we're going to move our fly all the way to the top left, and now we have a x coordinate of 0 and a y coordinate of 4. Check our answers. Everything checks beautifully. Now we have a little talk about it that says, how could we determine the dimensions of the ceiling from the coordinates of the four corners? Well, it went from 0 to 6, going side to side, so it has a 6-foot width and a height of 0 to 4. 4, I think it was actually meters they gave us. So to find the dimension, the area of that, we could even multiply 6 times 4, because area equals length times width, or base times height. And then you get the area of the ceiling along with its final dimensions. Now it tells us that the coordinates around the center include rational numbers. How are the coordinates similar to those you've seen before, and how are they different? Well, if we were to take and move around in here, you can see that everything comes to a 0.1, or a 1/10 section, or the nearest tenth in the coordinates. So that's how it could be similar to everything comes to the nearest tenth. But is it truly precise? I mean, think about it. You have to go, there's movement here in between. There's my 2/10. I go, okay, here's 3/10, go down. Well, now I was not working there, went a little bit. You're not getting its precise measurement, so I guess how is it going to be different is just kind of lacking in precision in the movements here. Now, so far, you've seen how Descartes measured the coordinates of the fly by noting its distance from the two walls. Is it possible instead to use a fixed point on the ceiling, such as maybe a light in the middle of the room as a reference? I don't think he had a light hanging in the middle of the room way back then, because they didn't have electricity and all back then, but it's possible. Okay, so drag the fly around. So now you've got your fixed point right here that you would have started from, and you can see that from that fixed point we get negative values as well. Negatives to the left, negatives are down. Now I go right, I have positives to the right, negatives down, positive and positive, negative and positive. So this point right here on our coordinate plane would be, let me go down to that one point at point 0, 0, and point 0, 0 we call the origin on our coordinate plane. Now it says to drag the fly to the center of the room, so whoop, right there, and based off of that location of the coordinates 0, 0, what do you think this represents? And that's going to represent the origin, as I just said when I was talking to you about it. Easy math. So now we're going to take the room, and then we're going to take and press the show the coordinate system button, and boom, all of a sudden we have turned this room into a coordinate plane. Now there's some things that I want you to notice here, and that is the quadrants. Your quadrants start in the upper right hand corner and they go counterclockwise around, opposite direction of a clock. And no, I'm not talking a digital clock, I'm talking about the roundy ones, you know, the ones that you were supposed to learn how to read like in first or second grade, but about half of you can't read still, and I keep it in my room just to torture you with it. Yeah, true story. So quadrant 1, quadrant 2, quadrant 3, and quadrant 4. There are 4 quadrants on the coordinate plane. What observations can you make about the x values and the y coordinates in each quadrant? Record your observations in a table on a separate sheet of paper. So what would we notice? And I'm not going to write it down, but I will tell you, in quadrant 1, both your x's and your y's are positive. Quadrant 2, your x values are going to be negative, your y values are going to be positive. In quadrant 3, your x values are going to be negative, your y values are also going to be negative to land here. And in quadrant 4, our x values are going to be positive, meanwhile our y values are going to be negative to land you in quadrant 4. If you know those rules, for example, positive and positives quadrant 1, negative and positives quadrant 2, if you know those rules, you can tell me where the point is going to land without even knowing what numbers the point represents. Now our new instructions say to drag the fly to the first ordered pair given on the table and press the mark button to leave a point. And continue for each of the remaining ordered pairs. Press clear the points if you need to start over, and press show the coordinate system button if you need help. So our first point is where x is 2, y is 0. So let's go ahead and, for example, let's go ahead and show the coordinate system because it'll be a little easier there. So where our x value is 2 and our y value is 0, I'm going to mark that location for our fly. Next we have x is 1, y is 1.7, so the fly has wandered back to where x is 1 and gone up to 1.7. We're going to mark that location for our fly. X is negative 1, y is positive 1.7, so we're going to go back to x is negative 1, y is going to be positive 1.7, which is right here. Mark our location. X is negative 2, and y is 0, so that's going to put him right here. X is negative 1, y is negative 1.7, so the fly wandered back to negative 1 and down to negative 1.7, which is right here. And then x is positive 1, y is negative 1.7, which means the fly probably just did a straight line walk to get to 1.7, negative 1.7, which will be right there. So now we have marked all of our points. What figure did you graph on the coordinate plane? I'm seeing 1, 2, 3, 4, 5, 6, a six-sided figure, which would be a hexagon maybe. So there's the answer for a hexagon. Check our answer. Our answer works. Easy math. Now I want to clear my points here for just a second because I want to show you a different way, the way I like to do it. Instead of worrying about flies and points, sometimes we get confused about where different points are and how to get there, because sometimes we confuse, does the first number our x or does our first number our y? Does the first number mean going side to side, or does the first number mean going up and down? And the way I like to look at that is Superman. Superman, and I'm not talking about the cartoon, Saturday morning cartoon Superman where he just says, I think I'm going to fly now, and he levitates himself up into the sky. I'm talking about the old black and white Superman. Before he could fly, he always did two things. He said up, up, and away, but he also ran. He would run 3 steps as he said up, up, and away, stick his arms out, and he'd fly out into the air. And that's exactly how your coordinate system works. Your first value is going to be Superman running. Your second value is going to be Superman flying. Superman's going to run left and right. Superman's going to fly up and down. Okay, so your first value is going to be the run, the second value is going to be the fly. I've also heard it as getting an elevator. You have to walk into the elevator first for your first value, and then you go up or down in the elevator after you walked into it. A couple little tricks to help you remember what the first value makes you do and what the second value in the ordered pair makes you do. And with that, we have finally finished the first resource of lesson, what are we on now? 5. Yeah, all right. So, the coordinate plane is formed by the intersection of 2 lines and an axis that meet at right angles at their 0 points. The intersection of the number lines separates the coordinate plane into 4 quadrants. The quadrants are listed as Roman numerals, Roman numeral 1, 2, 3, and 4, and I've already discussed that with you, so that should not be anything new. Now we're going to use a tool to see the quadrants or axis in which the x and y coordinates are either positive, negative, or 0. Choose a marker to select whether the x coordinate is positive, negative, or 0. The corresponding quadrants or axis will be shown, and then choose a marker to determine whether the y coordinate is positive, negative, or 0, and the corresponding axis will be shown. Alright, so here we go. If our x-axis is going to be negative, it could be either quadrant 2 or quadrant 3, and you can see that listed right here as negative. If our y-axis is going to be positive, that means it has to be quadrant 3. Negative 1 and positive, negative x, positive y gives you a quadrant 3. However, if our x is negative and our y is negative, it has to be, I think I said quadrant 3 here, that should be quadrant 2, and this one is going to be your quadrant 3. Now let's go back to the beginning. What if our x was positive? It would either be quadrant 1 or quadrant 4. And then if our y was also positive, it would be quadrant 1. However, if our y was negative, it would be quadrant 4. But what about the zeros? What if our y was on the 0 and our x was positive? Well, guess what? It's still not going to, that would actually be our x is 0 and our y is positive. That means our point would be somewhere on that line, but it's not going to be in any quadrants. Likewise, if say that we had a negative x value but a 0 y value, our graph would be somewhere on this line, but it is not in a quadrant. If the graph lands on a line, the graph does not land in a quadrant. So now we're going to use what we know about the coordinate plane to complete the tables. Quadrant 1, that's this quadrant here, our x value is positive and our y value is positive. In quadrant 2, that's one right here, our x value is going to be negative, while our y value is going to be positive. Our next one, quadrant 3, is right here. Our x is negative and our y is going to be negative as well. And finally, quadrant 4, this one right here, our x is going to be positive, our y is going to be negative right there. So we're going to check that, and that part checked good. Now, what if it landed on the x-axis right here? For the x-axis, that means that our x value could be positive, and if so, our y value would have to be 0, neither up nor down. If right here it landed on our y-axis, that means it would be on this line right here. The x value would have to be 0, the y could be positive, or the y could be negative. Now here, what if we have a negative x and a 0y? A negative x means it's here, a 0y means it doesn't go up or down, so it's going to land on your x-axis. And then what if we have 0 for your x, meaning it doesn't go left or right, and a negative number for your y? That means it's going to land on your y-axis. Check your answers, and everything checks. We are going to stop part 1 right here, come back and watch part 2 to see what else we know.